We have to calculate these two integrals, and the most appropriate way to calculate them is using a change of variable, right? So for instance, in this first one here, the change of variable that it looks appropriate is this one. If you have this, then t squared is the exponential minus 1. So the exponential is 1 plus t squared, and x is the logarithm of 1 plus x squared. If we take the, plus t squared. Okay. If we take the logarithm of the derivative of this, we have dx is equal to 2t 1 plus t squared dt. So you see, everything gets converted into a rational function, right? So one last thing, when x is equal to log 2, then this is 2, 2 minus 1 is 1, so t is 1. And when x is equal to 0, exponential of 0 is 1, 1 minus 1 is 0, t is 0. So the integral, this integral here, gets converted into the integral from 0 to 1, right, these limits. Then 2t times t, 2t squared, over 1 plus t squared. And we are going to add 2 and subtract 2 to the numerator, like this, right? Plus t squared dt. And we're going to separate out this integral into 2. So we have the integral of 2, and here we have t squared plus 1 over 1 plus t squared dt, minus 2, the integral dt over 1 plus t squared. This is just 1, right? So this, and the limits, I forgot. So this is just 1. So the integral from 0 to 1 of 1 is 1. So the first term is 2. And this is the arctangent, so we have minus 2 times the arctangent of 1 minus the arctangent of 0. The arctangent of 0 is 0, so this is just the arctangent of 1. The arctangent of 1 is pi divided by 4. So this is 2 minus pi divided by 2, or 4 minus pi divided by 2. Okay, this is the first. Now the second, for this second integral, the appropriate, well, you see a square root of x squared minus 1. When you see that, the suggested change of variable is x is equal to the second of t, or 1 over cosine of t, right? Then the second square minus 1, which is x squared minus 1, right? This is equal to the tangent square of t. Alright, so x squared minus 1 gets converted into the tangent square of t. And if you remember, the derivative of the second is just the second times the tangent. Okay, tangent of t dt. Okay, so well, one last thing, when x is equal to 2, we have 2 is equal to 1 over cosine t, which means cosine t is 1/2, which means t is pi over 3. Okay, that's the angle whose cosine is 1/2. When t is equal to 1, when x is equal to 1, 1, we have this, so the cosine of t must be 1. So t must be 0. Okay, so this integral here, the integral from 1 to 2 of the square root of x squared minus 1 over x, gets converted into the integral from 0 to pi over 3. And then we have to substitute. Here we have the square root of x squared minus 1, so that's the tangent of t. Down here we have x is 1 over the cosine, so we have cosine t here. And finally we have the secant, which is 1 over the cosine t times the tangent. Okay, at. Right, you cancel the cosine here, then you have the integral from 0 to pi over 3 of the square of the tangent dt. Okay, we don't know what is the primitive of the square of the tangent, but we do know what is the primitive of 1 plus the tangent square. This is just the tangent. Sorry, this is t. This is the tangent of t plus a constant, of course. Okay, that's the primitive, the tangent. So the primitive of the tangent square will be the tangent minus t, okay, because the primitive of 1 is t, right? So it's the tangent minus t plus a constant, of course. Then this integral here will just be the tangent of t minus t between 0 and pi over 3. Okay, now this function is 0 at 0 because the tangent is 0 and t is 0, so this is just the tangent of pi over 3 minus pi over 3. Okay, the tangent of pi over 3 is the sine of pi over 3 divided by cosine of pi over 3. Cosine of pi over 3 is 1/2. Okay, so we have 1/2 here. And this one here is square root 3 divided by 2. So 2 cancels, and then we have the square root 3 minus pi over 3. So that's the value of the integral.